Hello and welcome to part 5 of the chapter Triangles. So far, we have proved three theorems: BPT, areas of similar triangle, and the Pythagoras theorem. Today is the last theorem, and that is the converse of Pythagoras theorem. This is a relatively very easy theorem. Let's go to the statement of the theorem. In a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite the first side is a right angle. Exactly the converse of the Pythagoras theorem. In the Pythagoras theorem, we start with right angle and then we say square of one side is equal to the sum of the squares of the other two sides. Here we start with if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. Let's see the figure. Given in triangle ABC, you are given that AC square is equal to AB square plus BC square. But angle B is not a right angle. We have to prove that. But what we do is, we construct another triangle, PQR, which is a right angle triangle. Angle Q is equal to 90 and constructed in such a manner that AB is equal to PQ and BC is equal to QR. If we prove triangle ABC is congruent to triangle PQR, then angle B is equal to angle Q because they are the corresponding angles, and Q is 90, therefore B is also 90. This is the way we are going to prove the theorem. To prove two triangles congruent is also not very difficult, because already by construction what we have done is AB is equal to PQ and BC is equal to QR. Suppose we prove AC is equal to PR, then the two triangles will be congruent by yes congruence rule. Let's see the proof. We start with Pythagoras theorem. That is, we can apply Pythagoras theorem in a right angle triangle. That is, PR square is equal to PQ square plus QR square. But this triangle is constructed in such a manner that in place of PQ you can write AB, and in place of QR we can write BC. That is by construction statement number 2. Third statement is given. AC square is equal to AB square plus BC square. Now if you compare the second statement and the third statement, look at the right hand side. They are equal. Therefore, left hand sides are equal. PR square is equal to AC square. Therefore, PR is equal to AC. See, now go back to the figure and see. If PR is equal to AC, then the two triangles are congruent by SSS congruence rule. Angle B is equal to angle Q because corresponding parts of congruent triangles. But angle Q is equal to 90 by construction. Therefore, angle B is equal to 90. This will be the remaining step. Only the first three steps. We start with Pythagoras theorem, we go to construction and then given. After these three steps, rest are very, very simple. Let's see the remaining steps. Now we consider both the triangles. AB is equal to PQ and BC is equal to QR. This is by construction. And AC is equal to PR, just we proved from statement 5. Therefore, two triangles are congruent by SSS congruency. Therefore, angle B is equal to angle Q, CPCT, corresponding part of congruent triangles. Angle Q is equal to 90 degrees because triangle PQR is constructed with angle Q is 90. So from statement 9 and 10, we get angle B is equal to 90 degrees. And that is what asked to prove. Let's see the entire theorem once again. Yes. So we start with Pythagoras theorem in triangle PQR. PR square is equal to PQ square plus QR square. By construction, PQ is equal to AB and QR is equal to BC. And what is given to us is AC square is equal to AB square plus BC square. From statement 2 and 3, we get PR square is equal to AC square. Therefore, PR is equal to AC. Now we consider the two triangles together. AB is equal to PQ, BC is equal to QR is by construction. And AC is equal to PR is from statement 5. So we get the two triangles are congruent by yes, yes, yes congruency. Therefore, angle B is equal to angle Q, corresponding parts of congruent triangles. But angle Q is equal to 90 degrees by construction. Therefore, angle B is equal to 90 degrees. That is from statement 9 and 10. So far, we have seen 4 theorems, and you have only 4 theorems in this chapter. The whole chapter is based on these 4 theorems. We'll go to the objective questions. We will go to the short answer type questions. We will go to the riders where we are going to apply these theorems. So as far as though the portion marks point of view, one theorem will come for 3 marks. This year there are 12 marks, So remaining 9 marks. To score remaining 9 marks, you should know these 4 theorems thoroughly. That's all for today. See you next time with application type questions based on BPT and areas of similar triangle. Thank you.